Good morning, good afternoon, good evening, wherever you may be hailing from. This is the CIQ webinar series, and today we're talking about, wow, we're doing great. 7 seconds in. We're talking about GPU ready in minutes, AI development on Azure with RLC Pro AI. I'm your host today, Eric the IT Guy Hendricks. And as you can tell, I talk for a living. So it is a good thing that I have people that are much smarter than I am here to back me up. Today, we're going to be talking about how to use RLC Pro AI on top of Azure infrastructure to get to your first inference much quicker. We've got a few pre-recorded demos because let's face it, no one wants to watch a 4 gig AI model download in the middle of a live webinar. So we've pre-recorded a couple of demos, but should be a really great time. Love these guys, very smart people. With that said, let me bring in my returning guest, Mr. Brian Dawson. Brian, welcome. And for those that don't know you, could you give us the 60-second elevator pitch on who Brian Dawson is?
All right. Thanks for having me back, Eric. So Brian Dawson is a complex person. So I am director of product management, a director of product management at CIQ. I'm responsible for delivering on our so far proven thesis that the world needs workload optimized versions of Linux to close out at least 80% of that gap that people spend tuning general purpose Linux for workload. So in particular, I'm excited to have worked with a fantastic team here, to have recently brought Rocky Linux from CIQ Pro AI, optimized for AI workloads in production, to market.
Awesome. Well, thank you for coming back. You're becoming a regular staple on the CIQ webinar series, so I'm glad to have you.
Yeah, we're getting to know each other well.
At least picking on each other. There's that much. And also a returning guest. He told me in pre-show that this is his favorite thing to do week in and week out, is come up with demos and be drug onto recording. So with that said, welcome back, Mr. Brian. Brian. I looked at Brian and said, welcome back, Damon Knight. Damon, could you introduce yourself?
Yeah, absolutely. It's good to be back, Eric. Thanks for having me. As Eric mentioned, my name is Damon Knight. I am a senior principal automation engineer at CIQ, and I'm kind of our in-house general purpose AI nerd. Love it. Spend all my time breaking it and doing horrible things with it. It's great. And in my spare time, hopping onto webinars with wonderful folks like you.
Awesome. And so for the second webinar in a row, we actually have a not CIQ guest that I'm really excited to introduce. This webinar wouldn't be possible without our friends over at Microsoft Azure. And joining us is our friend Hugo from the Azure team. Hugo, could you introduce yourself?
Hey, Eric and team. My name is Hugo Meiland, part of the Azure core engineering team. Our larger team is responsible for all the specialty VMs in Azure. That means anything with the GPU card, InfiniBand card, or any kind of other accelerator. Also, we own the different software tools that are being used in the HPC environment. And of course, we've seen a huge jump on the AI usage. So really glad to work with you guys on releasing this new AI Pro image with CIQ, and hopefully present here some of the goodies out of that.
For sure. I have previewed the demos, and they're just really cool the way you can get from, it's the Azure Marketplace, to I have a thing that I can ask questions to. It's so cool. I'm really excited about today's topic. That said, if you are watching us live, there is a chat function in your window. Feel free to give us a shout out. Let us know where you're listening from. And if you have any questions for my amazing panel of guests, feel free to just throw your questions in there. We'll do our best to address those as we go. If not, we'll have a dedicated Q&A session at the end of the event. Also, the CIQ team is available for you to reach out and ask any questions that you may have, whether that's sales or support. We are here to help you. With that said, that kind of brings us to the end of housekeeping and introductions. So let's dive right into this. I want to kind of talk about kind of the state of AI as a whole. I want to start at the kind of the industry level and kind of work our way down into the nitty gritty. So just about everyone I know, every systems engineer, every automation engineer, Damon, are working towards this idea of I can write a script to do this, or I can write an Ansible playbook to do this. But what if I didn't even have to do that? What if I had a thing that I could just talk to, and it goes and does some other things? And so just about every organization out there, everyone that I talk to in my network is talking about the same thing, AI. And we all know that GPU infrastructures, our GPUs themselves are kind of hard to come by right now, which is probably why we're talking about Azure today. But Brian, I wanted to pick your brain. Is that kind of what you've been seeing in the industry? Kind of this frontier approach to this technology?
Wow. Well, I personally, I've probably been seeing a little bit of everything in the industry, right? And I think if we lean into your statements in the part here, what I've seen a lot of is I've seen individuals and enterprises on a fairly consistent journey when it comes to understanding, adopting, and productionizing AI. And I'd say, largely that goes from exploration to experimentation to implementation. What are some friction points we've seen? A couple of things is, look, getting GPUs is hard, right? Two is there's this, pretty rapidly developed technology that most people that are working in an enterprise environment are kind of forced to quickly learn and understand, right? So I've seen a couple of things happen here. GPUs are hard. I don't fully understand it. So I'm going to outsource the stack. I need our cloud providers. I need people like Azure to make sure that I can tackle this journey at the pace that I'm being asked to do. And that sort of, helps overcome the hardware. Now, I also think, and as we'll talk about today, we're seeing this individual journey of I've started exploring with AI on whatever hardware I have available, my corporate laptop, my home laptop, a desktop, and I've gone from exploration. I'm well into experimentation, and now I need some more serious horsepower underneath what I'm doing. And that's, an opportunity to, yes, I'm going to move to the cloud, or yes, I'm going to, stand up a more efficient box. But then I also have to overcome a skills gap, which is what is the OS that I can lay down and run that will allow me to leverage my hardware, set it up quickly, and spend less time with it. Right? I think it's those problems where we're sort of intersecting today here with Microsoft to solve.
Yeah, I would definitely agree with that. It's a challenge, and one thing we didn't mention.
Well, if you told me you didn't if you told me you disagreed, it would make it kind of awkward there.
This is true, but one point we didn't talk about was this idea of sovereign AI. Sure, I could go spend $19.99 and go spin up Claude or ChatGPT, but do I really want to do that if I have personally identifiable information, if I have health records, if I have financial records, if I'm working, say, on a roadmap for a proprietary piece of software that my company's going to be releasing? Do I really want to expose that to something that may or may not be available to my competition? So this idea of sovereign AI comes around, where I can host my own instance, my own AI, and I can train it on my own data and really fine tune its responses for something specific.
Yeah. And I'd say, and by the way, just to add to that before we move on, and in that, just can I own more of the stack, right? From the hardware up. When we talk sovereign, there's the building, fine tuning, and hosting of my own model, so I don't have to send it out over an API. But then, as we talk about here, sort of AI in depth, to borrow from defense in depth, right? Can I have some confidence in sovereignty by knowing that I've built and I control the stack all the way up to that frontier model?
Definitely.
What
So just kind of work.
Just to have a remark on that and what we see, and that is really important. I mean, the whole sovereignty question, I think we can talk 2 hours on that alone. So I won't go into too deep on that, but talk to your account manager and they can tell you all the precautions that we take at Microsoft to make sure that your data is secure. And we have a whole statement on that. Anyway, coming back, and that is one thing I think is really important. Working with Linux in an interactive way and being able to understand and build your own stack and working with that in detail is, I think, one of the biggest reasons why we wanted to partner with you so dearly to make this happen. That point of learning, understanding, and growing with the stack and with the operating system is I think the emphasis here that we see that a lot of engineers, developers, data scientists are actually asking for. Yes, we have Foundry AI, we have these big SaaS platforms where you can do your AI, but there is the point where you say, hey, I want to understand it. I want to work with the nitty-gritty details. I want to be able to tune it, change it, modify it, and be in this open source environment where I have the freedom to make my own choices. So yeah, this is really what we're hoping to get out of this, and what you guys demonstrated that you can deliver on. So thanks for that.
That's awesome, and really appreciate the input there. In fact, that's kind of a lead into my next question of what are you seeing from the Azure side? Are you seeing kind of the same thing? People are looking for opinionated builds?
So, and you have to be a little bit careful of my role, and I'm sort of like not entirely objective on that point. In my role, I work with some of the larger partners and customers on Azure, and therefore I always have this sort of like predefined idea of we're working for enterprises. If we deploy something, it doesn't only need to scale for the engineer and the 10 people next to them, but also for the 5,000 people that are working globally on this same, and want to use this same tool or grow even further. So from that perspective, that view is a little bit skewed. But what I am seeing is that especially data scientists and engineers that really want to understand it, don't just want to use a tool and click together something that works, but want to take the next step and understand, like, hey, what do the models do? What does it actually do within the computer environment, in the operating system, with my memory, with my GPU? That is the point where we see a strong ask on how do we do this in a Linux environment that we can easily use, easily set up, get started, and get to let's call it production. I mean, don't call it just a playground, but to a production environment and make that next step.
That's awesome. So, Damon, I know I've asked you this in previous webinars, but your answer is just so beautiful at this point. It's like I've asked you this a half dozen times. But what before getting something like RLC Pro AI involved, what does a typical deployment process look like for an AI workload?
Yeah, you do enjoy tormenting me by making me remember what my life used to be like. No, it's
a little PTSD.
A little bit, I've done this process so many times at this point, right? On so many different Linux flavors, Ubuntu and Red Hat and SUSE and obviously RLC. And depending on the specific OS version you're on, the hardware you've got, what you're trying to do, man, good luck, right? You have to figure out the right drivers, and are you getting the open source drivers, the proprietary drivers? Are you getting the data center drivers? Are you getting the consumer drivers? It's a billion things. Do you have CUDA? Are you getting Torch? My story that Eric always loves, and because I pick on Ubuntu a little bit, is Ubuntu 25 and Ubuntu 24. If NVIDIA doesn't ship all of the things for Ubuntu 25, you have to know that you need to go and install the 24 versions. Oh, hey, the drivers come with CUDA. but not the CUDA toolkit. And you probably actually need the CUDA toolkit and you don't even know it, right? Is Torch compiled for your CPU or your GPU? Boy, I sure hope you remembered to compile it for your CPU, or you're going to be wondering where all of your tokens went, and if your very expensive GPU is broken. There might be reboots involved. I mean, this is best case scenario. I've done it with a copy and paste with a checklist in front of me. It's a 13-14 minute job, best case, if you get lucky and there's no reboots. But no one is getting that lucky, right? Realistically, you're spending hours to days researching up front to find all of those things and put your checklist together. Or if you're not, you're discovering that you did it wrong and you're going back and fixing it and rebuilding. It's not something that I like remembering, but it is something that I really enjoy not having to think about now with RLC Pro AI, since I can just, I install and now I can just start doing whatever it was I actually wanted to get done.
If I may add, Eric,
of course.
So a couple of points on this I'll try to hit real quick. So thankfully, we have Damon here to feel the pain on a regular basis, right? That I don't have to. Now, I myself, we'll talk a bit about prosumer hardware, right, and what we support and what we've deployed against within Azure, right? Real sort of data center scale hardware as well as prosumer hardware. Look, I myself, like a lot of like you would see with data scientists and researchers or people early on. However, I haven't had the privilege of having access to that. I haven't had the privilege of a laptop with a 5090 in it that I can work against. I, had to buy my Dell, set up my Dell. And frankly, with all of the reboots, the Nouveau blacklist, I've lost my card, I'm now headless, I need to SSH in. I was originally embarrassed to say I suffered in quiet that when all was collected with other things I had to do, I spent days getting my box set up. Right. And as I said, look, it arrived. I couldn't wait. This thing is going to land. I had a whole exciting 24 gigs of VRAM, and I'm going to do all these things. Flash forward 4 days later, and I'm just kind of getting started. So I've sort of felt the pain. And when we talk about the individual journey, I think we see a lot of that. Now, the other thing I wanted to add is, I have the privilege of briefing analysts as we went to market. We had a lot of debate internally. Like, what number do we put on what we're saving with setups? Damon has some firm and exciting happy path numbers, but what does it look like in reality? Ultimately, because we tend to deal with very deeply experienced system administrators that have been dealing with accelerators and accelerated ML workloads for years. Like, well, yeah, you know what, Brian, it's not that hard, right? I then got on, I briefed analysts. I said, hey, we save people, 30 minutes to a couple of hours. Guys stopped me and said, I love everything you're saying. Everything you're saying is right. But you guys are woefully under indexing the pain that it is to set it. So I just want to close in a little longer. But Damon, to your statement of, I think you said no one experiences the happy path, and I'm starting to get signals that that may be very real. So.
Well, it's one of those rites of passage nowadays, I think, before you just go and use a tool like RLC Pro AI, just like in the automation days, before you go and automate something, you should build it by hand. You should definitely go out and try and get Ollama running by hand with all of the Nouveau blacklisting, with all the driver matrix, trying to guess which versions. And Damon pointed out, I like to pick on Ubuntu only because they're just not enterprise Linux. But it's kind of a rite of passage. But once you've done it once, you've got work to do. And if you have a fleet of 50 servers, you don't want to have to go through this and play with it, because those numbers are anywhere from 13 minutes to 4 days. As a systems administrator with a deadline, I can't tell my boss, I don't know, it could be done this afternoon or it could be done next week. That just doesn't work when you have some kind of a capital project. And so what's nice is I can obfuscate a lot of the hardware questions away by just using the Azure Marketplace. And then with RLC Pro AI, I can obfuscate more of that away by using something that is pre-built. And I always warn my guests that I tend to go off script, and I'm about to do that right now. So apologies to the three of you, but there's this whole idea of just trying to get the most out of your system that you can without having to sacrifice too much. Is the investment up front worth the time savings later on? So actually, no, I'm not going off script. So yay me. But for years, I would go out to the company's website. I would download the ISO for the latest version of their Linux distribution, whether that was CentOS or Red Hat or Rocky, whatever the case may be, downloading that ISO and just installing it on a pile of Dell PowerEdge servers, and away we go. And then you just kind of tweak things as you went. But I think we're at a point in the industry where that just isn't going to work anymore. Workloads are far too demanding on hardware. Hardware is far too scarce. It is far too expensive to expand or replace hardware with the state of the economy these days. So you're in a position where you've got to collect every bit of horsepower out of your systems. And Brian, I think you said something brilliant, but you were on mute.
Always brilliant when I'm on mute, as you know, but not as brilliant when I come off mute. No, I was going to say, or just to leave it idle, right? A GPU hour is very costly on many dimensions. So I was just adding that, right? We want to get the most out of it in terms of when it's running. Are we maximizing it, right? But if I secure an instance on Azure, a bare metal instance on Azure, and I'm waiting while I'm tweaking and getting my stack built out and going, there's real opportunity cost, and that does also factor into your utilization. Right?
Mm-hmm. It goes even further. What we typically see from users and engineers who want to do a retraining or fine tuning like every 2 weeks or so, they're not going to build up and sort of like rebuild that complete system every 2 weeks. They need something where they can be up and running really, really fast, use that GPU and give it back, because I mean I know it's pricey, and we have the possibilities and I think that is one of the unique propositions of doing this on Azure. I know that you want to do this on your laptop or on a bigger machine at home or in the office, but at some point you need that big, what is it, H100 with 80 or 96 gigs of memory, because you need to have this model that you need to validate, like, is this the way to go? You want to train it for fine tune it for a couple of hours, and then get off of it and be able to compress it and do inferencing on a smaller environment. So those are the kind of tricks where we try to help you in giving that environment for a couple of hours. And then you need to be really, really fast in deploying, getting it up and running really quickly, and do something effective and useful with it.
Mm. Yeah. So this is probably for Damon and for Hugo. We're seeing this drift away from general purpose Linux, which is kind of what we're talking about here, just installing hardware, installing an operating system and going. What is it about these AI models that makes it so demanding on this hardware?
Yeah, we've talked about this a little bit in the past, right? General purpose servers that we've all lived with for the existence of the internet, right, have basically been very, very general purpose. So cool, right? You throw an operating system on it and it's just going to work and do what you need, and like everything else tends to be software. And now we're entering this world where, oh crap, right? The hardware really matters, and it's not homogeneous, right? It's really different. It's really varied, and it isn't just a matter of, oh, right, I throw a piece of software on there and I'm good to go, right? Again, we said before, right? It's that, is it the right software for the right hardware and configured in the right way that's going to work together? And we can't, we can't make the assumptions that, oh yeah, it's just gonna work. That you can make where, if you're just writing some code for, an x86 instruction set, we know how to do that at this point, right? It's not that big of a problem. we're moving the workloads from being in, CPU and kernel time to, oh, hey, this lives on a PCIe device or, an HBM or whichever crazy things NVIDIA is coming up with now for memory bandwidth. But right, it's we don't want to talk to the kernel. We don't want stuff to go there. So scheduling changes, like so many things just don't apply the way they used to in this kind of AI world, at least yet. Who knows what the future holds?
It's awesome, and I'm really, you probably see me smiling and smirking while you are saying this. So I come from a different background. I've been doing HPC for all my life now. So I would say close to 30 years, having supported national supercomputing systems and METEO supercomputing systems for a long time. So it's so awesome that this point of getting to specialized hardware and really drive that ability to use that hardware to the last possibility and push it to the edge, that is now coming to the engineers and the data scientists, the normal people, so to speak. So that is really awesome, and that is one of the things where I think that and we probably go a little bit deeper into the kernel tuning and the things that you are doing in this specific distribution and OS for pushing those boundaries. But coming out of the HPC world, this is really awesome to see. And like I would say 5, 6, 7 years ago, we have been looking at how this AI has been sort of like stepping up. And nowadays we see that especially NVIDIA is making those choices in their newer generation of GPUs to say, hey, we're stepping away from double precision. And on the other hand, we're putting in this FP8, FP4 capabilities specifically for AI. So we're driving real change on silicon to support this new world in a more efficient way. That's awesome to see from a technology point of view. So and yeah, it's really important for the new data scientists to be able to make use of it. I mean, it's there. It's going to be. We're going to have more and more exotic. I call it exotic, specialized hardware, and we're doing it the same. We have the Maya GPUs now online for our production workloads. And we are already working on newer generations of that. And we're going to see that more and more. So, yeah, I hope that answers.
I mean, to be fair, I think exotic sounded a little cooler.
I
go back to the exotic hardware then.
you trigger for me, and I'll call out, look, as a person that, I joke getting a little personal. My dad did computer-aided design, was a mechanical engineer. He used to worship the Cray. I walked around with your pictures of Crays around my house. But HPC is new to me coming into CIQ, frankly, right? And it is actually exciting to see this exotic thing. That's for you, Eric. This exotic sort of technology practice and domain kind of move out to the masses and me to sort of understand it. You just triggered for me. I just wanted to get in this idea, of course, of what we're hearing from AMD a lot. We're hearing it from NVIDIA. But it also speaks to general hardware, software life cycles when we're looking to get the most out of the hardware. And that's hardware and software co-optimization. I did have the privilege of early in my career working closely with Shinji Okamoto-san, the person that designed the geometry transformation engine for the PlayStation, and him telling me as a young engineer, Brian, what's important with what you guys are doing with the libraries and software is we have a thesis. We bake it into the silicon. You guys then go out and use it. We learn from what you do and we iterate and we bake that back into the silicon, right? Sort of this hardware software co-optimization that we're seeing happen at a rapid cycle now. What gets me excited here about this conversation is Pro AI, conversations that we're having about the RTX, the 8100, and our work with Azure is a version of that hardware software co-optimization cycle, right? And I think what we say is, the OS itself can't live in isolation. That's kind of what Damon said and Hugo said, right? And this important, expensive hardware can't live in isolation either. They need to be co-optimized together.
Yeah, it's a symbiotic relationship between the hardware, the firmware, the software, the end data that comes out of it. It all has to work together. It all has to be working out of the same playbook, the same thesis, to use Brian's word. And I think that's really
thesis,
important.
Eric. Exotic thesis.
Exotic thesis. Would that be
This
exotic?
is going to hunt me. This is going to hunt me.
We take ourselves just seriously enough at CIQ. So I want to show this off. Damon spent days before he took some PTO getting these demos together. Again, they're pre-recorded. Normally, anyone that has followed my career knows I love live demos, even when they blow up. But I don't want to sit here, and I know you don't either, want to watch 4 gigs worth of AI data download off the internet. So we're not going to do that. Instead, I've taken Damon's demos and kind of compressed them down, and we've sped up some of the package installation pieces and that kind of thing. So we have pre-recorded demos, but I promise you that they're genuine. I have Hugo here to validate, just to say that yes, this is Microsoft Azure, and I've got Damon here to validate yes, this is RLC Pro AI. So we've got a couple of demos that I want Damon to introduce. I figure maybe we start with Jupyter, but before we just dive into the demo, can you explain for the uninitiated what Jupyter Notebook is? Because when you get into AI, the Jupyter's everywhere.
Yeah, it's. I'll be honest. It was a new tool ish for me. I understand that in certain parts of the industry, it is really, really popular and well known, especially among data scientists and AI and ML folks, because it's basically a really cool, friendly web interface to live work with Python and other things. It's a little hard to really kind of sum up because it's a weird and really powerful tool, but it's kind of great, right? You have a document, you can write code and run it and see your results right there, and like have multiple people interact with it and all that. But for the purposes of this, we just threw together a quick demo to show it running on an H100 system in Azure and validating that it can talk to the GPUs and use Torch and all that cool stuff.
Just a quick remark, Damon, and I know that you guys you can see the age of people on sort of like the color of their hair, and I'm starting to turn gray here as well. But you know that you can read so much about the editor and the tool they use. So SSH and VI is definitely for the computational chemistry folks. They won't walk away from that. The mechanical engineer and the CAD guys, they stay on these GUIs. They want to have a mouse to click towards. And what I've been seeing, sort of like in my time at the university, like 50 years ago, the Jupyter was sort of like coming up out of the biosciences groups. Bioinformatics, that is where it came from, and the AI folks adopted this really, really fast. And so yeah, and cool for you guys to see that this is being adopted then as a standardized tool in this environment as well. So awesome.
All right, so I'm going to pull up your demo here, Damon, if you want to walk us through it.
Sure. So this is a brand new, like just installed, did nothing to it, RLC Pro AI host in Azure, and I SSH in, and I'm immediately just, hey, let's get Docker installed and set up, and basically that's going to go straight from this to basically saying, hey, let's use NVIDIA for the container configuration so that it can access the GPU properly. So this is all just the standard Docker CE installation. Nothing too exciting yet. But again, right? This is time where again, I'll pick on Ubuntu, but pick OS of your choice. You're installing drivers at this point.
And then we're just going
Docker
in and
probably not entered your mind,
right. Just enable and a start there for Docker.
So as a remark, and that is something I will work on with Damon as well, when doing this kind of tools, it's good to learn a little bit on how the Azure VMs look like from a hardware perspective. The good thing is they're homogeneous. If you pick a VM type in every region, they're exactly the same. So especially when running these containers, there are, of course, it's the base OS image where a lot of the stuff is, but there's also a slash mount or a slash mount resource disk, which is actually a local SCSI or local NVMe disk that gives you a lot more performance, especially if you're pulling in some containers which are sort of like intermediate data anyway. So put it on the local scratch disk and take that extra performance.
Nice. There you go. Good tips from Hugo.
I was going to say, I wouldn't have even thought to look there for something like that. That's awesome. So let's see. Looks like we just installed the NVIDIA Container Toolkit.
Yep. So now we should be getting ready. There we go, to make that be the runtime. And now restart Docker so that it actually does that. Again, this is just going, hey, let's use that GPU. Let's not use the CPU. And this real quick is just doing a quick, hey, let's pull a quick container and run NVIDIA SMI from within it to validate that it can in fact see the GPU. There we go. There is our H100 system. Again, this is just making some folders and then configuring the actual Docker run. You're gonna notice here I'm setting up a port 8888. This is the port that Jupyter Notebook is going to be looking for. And I believe there are some, here we go, the token, which is just basically a quick initial password that we put on it. Since I do open these up to the entire world while I'm filming these demos, I like to leave a password on it just to be safe. Don't ask me.
Now you've
why.
published your password to the entire internet as well. So
Exactly.
now you're gonna have to change your password.
Exactly. And here you go. It's downloading all of the containers and all of the necessary pieces for Jupyter Notebook. Thankfully, this one is relatively small as our demos go. Again, here just kind of demonstrating in the Azure portal, me creating that really terrible open to anyone in the world 888 forward that I don't necessarily recommend folks do for real. But
just to be sure, there is this button on top when you do that just picks out your own IP address where you are coming from the portal. So
I do
any as a standard.
Yeah, when I do that for real things I'm building, I always click that button. That button is my friend.
Yeah. We're monitoring the security, but I mean, yeah. I have to be careful of saying we can't fix stupid, but yeah.
I didn't hear anything. Did you hear anything?
No, good.
And so from here, right, we can actually browse to the port, the container's up and running, log in with that password, and here is Jupyter Notebook. And I'll go ahead and I think that's in the next video, I'm guessing. Fire off.
There it is. Oh,
yeah.
I was having some video issues earlier.
All right, that's okay. We can watch me re-add the security rule.
That's actually the end of the video there. So apparently even pre-recorded demos are not infallible. Can you walk us through what that final step would have been? Apologies.
Yeah, so the final step, honestly, was just pasting some Python in that basically did some tensor math to validate that it could see the CUDA cores and could do tensor math, some basic multiplication and stuff like that. Nothing too fancy or exciting, but just kind of showing that last little bit of Jupyter Notebook actually running some sample Python code. Thankfully, for those of you watching, I'm sure somewhere we're providing links to where we have documentation for folks who want to run these demos. Those links will include all of the things, including that copy-paste Python, so that you can follow along and see for yourselves that it does in fact generate beautiful output.
Damon, can I ask? I get a comment. You and Eric have spent time on this. Of course, we all have collectively worked on it a bit. You've carried the work. Is that was effectively real time, though there was some chopping and compressing. That was effectively real time, right? And
Yep.
Damon, at this point, I'm still trying to find the right drivers and compile K-mods. I think usually.
Yes,
right?
yes.
Okay.
At this point, you have not even gotten to the beginning of this installation process on anything else. All right, let's see if this time it likes me better. Yeah, there we go. Again, just really basic matrix multiplication with CUDA.
H100, yeah.
And there we go. I clicked run, it ran, and there we've got some output and the demo complete.
Nice.
That's so cool. And, shame on the host for not double checking the video before putting it live on air. But I don't know. Kden Live today was being fickle about anyway. Joys of being in technical marketing. So that was just Jupyter Notebook, just getting something spun up. It actually took more time to get Docker installed and configured correctly than it did to spin up an application as complex as Jupyter Notebook and then just do some basic hello world type operations on it. So I find that deeply enjoyable. But we have a little bit more involved demonstration that I'm really excited about. You want to tee that one up for us?
Yeah, this one's really, really cool. So there is an organization, open platform for enterprise AI that Microsoft and some other folks are participants in. And they've built some really, really cool proof of concept and reference implementations of all these cool generative AI microservices and mega services. And one of the ones that they've got there is this thing called CIQ and Microsoft, which is a cool mega service that lets you basically build a RAG chatbot. Right, retrieval augmented generation, something like that. You throw docs in it, it can read the docs and kind of answer to your documentation. It's really, really cool and shockingly simple and straightforward between RLC Pro AI and the great references that the OpenEA folks have created. So let's just jump right on in.
Sure.
This one I'm actually doing on a slightly different host. I think I ran this on an RTX host just for good measure. And we're going to run this with the Microsoft Phi 4 model as the back end, which I think is extra cool. But what you're watching here is the same thing, actually, that you just watched in Jupyter Notebook. Where do we start off? Actually installing and downloading Docker. We don't need to spend a whole bunch of time on CUDA and Torch and all these other things. We can skip ahead just a little bit. That said, I will caveat, at least at the moment, on RTX systems, you do have to install grid drivers. We're working on it.
So just as a heads up on that one, the RTX in Azure is not generally available yet. So we are working in this in a preview mode. We expect the RTX to be released in GA in the next coming weeks. So then we'll follow up with the team on help them getting the drivers just right in it. But already the work done on this is awesome.
Yeah, and huge thanks to you also for getting us access to RTX hosts to build these demos on and experiment and all that. It has been really fantastic.
Yeah, and that is what we do with quite a few partners and larger enterprises, is work in the preview, make sure that we get feedback on what's happening, what's good, what's not good yet in the platform, how can we improve this further. And we do this with a lot of our hardware and new releases, both on the GPU and CPU side of that.
Oh, cool. I didn't realize we were getting a sneak peek here. That's even cooler. All right, so we're installing the NVIDIA toolkit.
Yep. Again, still exactly the same procedure we just did for Jupyter Notebook. If I had been running it on the same PC or on the same server, obviously I wouldn't have needed to redo that process. But I did want the excuse to poke around at the RTX hosts a little more. So.
Well, this is telling the sysadmin in me that we should write Ansible playbooks that do all this ahead of time, and then we have systems ready to go. We don't have to install Docker.
I'm sure we've got some things in the pipe for down that road. But here we go. We're now actually doing some LLM stuff. We're installing Ollama. Ollama is what gets used as just kind of the backend LLM server for this. So this is going to be downloading Ollama, and then I think the next step will be downloading the Phi model, probably. So it's the downside of things that I filmed a week ago, is I have to remember the order that I did things in a week ago.
And I didn't trim this one up as well as I did the Jupyter one, but.
And you know, it is crazy. We talked about, you know, or you talked about, right, the joy of waiting for it to download, you know, a 4 gig LLM thing. That's nothing. That is nothing. If we were showing, you know, our LLM training demo that we're not showing here because of time, that's a Llama 370B model. That's 70 some gigs to download. Yeah, it's not fast.
How big? Oh, go ahead, Eric. Sorry, excuse me.
I was just going to point out that I think that video that you sent me was like over 40 minutes long.
Yeah, that's a long one. And yeah, here you go. So the 5.4 model that's downloading now is about 10 gig, not much more reasonable.
How many parameters in the 5.4? I'm curious, do you know?
Oh, I'll be honest, off the top of my head, I don't recall. I don't know if Hugo would happen to know, but I'm just going to put him.
No, I'm going to guess.
Yeah,
I'm going to be guessing, so yeah.
Okay, fair enough.
Let's not do that.
So there we go. We've got the model, just making a lovely little folder. And then I am going to get things actually installed. Oh yeah, my Hugging Face token. Please don't steal my Hugging Face token. You can if you really want. It's a demo token, so I'm okay with that. This is really the hardest part, honestly, is this right here. There's a really big copy and paste of some YAML, and you're going to see here, well, very briefly on the screen, there were a bunch of IP addresses. When you're copying and pasting this from our demo, it basically says, hey, you need to replace all of these with the IP address of your host. Make sure you go do that. But then you just run a Docker compose on that, and it downloads and installs all of the pieces. Again, we have that config available for you all in our documentation, but also this is just the OPEA reference implementation, right? You can go straight to the source. You can go to opa.dev and get that from them as well, and customize or change whatever you need. You know, change the model, change where it runs, change whatever. This is very, very flexible, but it is just kind of a pain. There is a bit of a copy and paste there. There's just no real getting around that one. And yeah, here you go. You can see it just kind of grabbing all of the pieces it needs for all of the different containers. This is kind of the neat thing about that mega service concept that they have. It's a whole bunch of microservices and regular services all kind of bundled and packaged together so that they can ship as one while still all running in their individual containers and all that. It makes building this sort of thing really easy.
Yeah, they've got Redis, they've got Hugging Face, they've got Nginx. They've got a number of components pulled in there.
Yeah, what the guys from OP are doing an awesome job there. We are working with some other teams as well to see if we can improve that further and more tuned towards Azure. So what you're showing is already some awesome results there. So yeah.
And that's honestly one of the beautiful things about going with a platform like Azure is there's a lot of optimization that goes on between the hardware and the operating system already built in. And it just makes things work that much better out of the box, especially with something as finicky as running an AI model. Yeah,
that's what we're really trying to do. So one of the benefits that from distance, is like we have certain generations of VMs, and since they are, like I said earlier, they are homogeneous worldwide. So we have set on a certain design, and we can work with the different technology teams and partner teams and firmware and stuff like that to really optimize it and fine tune it to that. And for the partners, it also gives them a standard that they can trust. They know that if you start adopting, like you're doing right now, we're working on the RTX preview. The RTX is going to be there for a couple of years. You know that you're investing in a platform that's going to be available for quite a while. There's going to be a lot of large enterprises working on it and adopting it. So you know why, as a partner, you're investing your time into making that work and fine-tuning on that particular environment. That really helps.
That's cool.
So yeah, we're just at the phase of the demo where I'm reminding everyone that you need 1 million firewall ports for this particular demo. This one require quite a few, as I remember. Because what, this one gets 8080, 8888, one in the 6,000s.
I was going to say, you do know that you can put it in as comma separated values in a single line?
I actually didn't know that. That
good learning.
I don't know about my cohorts here, but that's why I do demos and stuff. I learned so much from building something that I know I'm going to have to show to others.
Yeah. All right, so here we go. We're into chat Q&A now. So I believe the next part of the video is going to be me uploading a document. I went on Google and I found actually it's me re-showing the ports. That's fine too. I went on Google, found a lovely doc, a PDF doc from Microsoft, from Azure, about RTX hosts on Azure, which is what I'm uploading here. And then I'm going to ask the bot about RTX on Azure. The upload, sadly, does take a moment. I will also pre-warn folks, we're watching, when I ask it a question, it's going to be a little slow. You're going to go, damn, and this is on an RTX. Why is it a little slow? It's the first prompt. It doesn't have that kind of cache warm-up going on. As you ask more questions and things like that, it'll be a little bit speedier, but you know, it was one of those things where even when I was filming it, I went, "Oh yeah, this feels a little slow. I should say words about that."
Well, you also started out with a very vague question of, just tell me about this.
Oh, I wanted to do some work.
It has to go through the whole model for this.
That's really true.
I'll note that we very heavily focused on where we think there's a lot of the cost is spent in both training and inference, and that's throughput. But as we move forward, we'll be putting more focus at the OS layer with Pro AI, RLC Pro AI, on tuning for time to first inference, time to first token, and latency reduction, as well as we look at agentic workflows, focusing on cold boot for agentic environments.
And so there you go. You can see, yeah, it took almost a full minute for that first query. And follow-ups would be much faster. It's that initial warm-up is always a little bit rough. But you can see it did actually give us answers based on the contents of that PDF document. So there is now a successful chatbot running a RAG. You could upload more docs. You could ask it more questions. For the purposes of the demo, it ends there. But from here, 10 minutes of time, and we now have a functional RAG-enabled chatbot. How cool is that?
Nice.
Awesome.
And you mentioned we have documentation that walks people through this, right?
Yeah, I'm not going to promise that I know where it wound up, but there are docs somewhere. There is a GitHub repo that includes some sample training data that we used, and some helpful scripts that folks can optionally use on some host types, just to make the process easier and simpler and things like that. I'm going to look in Brian's direction that hopefully he knows where docs have landed.
What we'll do is we will, I won't, well, it's actually at https:/:. I think we'll coordinate to make sure that those get posted with show notes. There's also documentation on learn.microsoft.com, which will coordinate getting people pointed to that, to walk through this and a few other really important demos that Damon has cited that he's built out that we didn't have time to show today. Definitely.
So we've got just a couple of minutes left. So Hugo, I want to start with you. 90 seconds. What is Azure working on? What can we expect?
Oh, I'm not sure if the public did the NDA signing here. No, I mean there are a couple of things we do and which I think are really important. And this RTX, the RTX 6000 Pro, as a foreigner, it's sort of like hard to stumble over the term. But this is our newest GPU in the fleet on the what are called the NV-series. So these are meant for GPU compute and AI on a relatively small scale. That means that you can get a VM with either 1 or 2 GPUs. If you want to have something more compute intensive, you can still use the H100s, which you demoed as well. The good thing about that from a scaling point of view is that if you pick the VM with 2 GPUs there's an NVLink interconnect between the 2 GPUs, so the communication between them is going to be even faster. For our larger scale, we do have, and to be honest, I'm not entirely sure of what is being announced, what is public at the moment. We know that the GB200, GB300 are being deployed as we speak. The newer generation is being worked on as well. Again, I don't have the details right now. From the CPU perspective, because CPU is definitely not that. One of the awesome things that we are working on currently is the HBV5, which is an AMD-based CPU, but has the HBM memory of the GPU architecture. So you may have heard about the MI300, MI300X, which is the AMD GPU. There's actually been talking about back in the days an MI300C, which was the CPU variant of that GPU. That is one we have, the HBV5. We're working with different partners to do both data preprocessing for AI on that, and also working on different HPC simulation. Like I said, I am working a lot in the HPC domain. So that's going on within Azure, and especially on the AI side, this release of the new CIQ Rocky image specifically for AI is going to be really important in helping us move the data sciences further in the Linux environment. So I think the demos here, Damon, thank you so much for creating these demos. These are going to enable a lot of older and newer folks to get their hands on doing actual AI. This is important. AI is not going to go away. It's there. It's going to stay. It's going to be bigger. Make sure that you get your hands on it. Make sure that you start to learn how to use it, both from a LLM point of view, like talking to it, using a chat engine to enhance the way you work, create your code, and like Damon just demoed in the chat Q&A, making sure that you use AI as tools to enrich the data and the data sets that you have and make it available to others. So hope this helps.
Awesome. Brian, how about you? What's coming down the pipe for RLC Pro AI?
Man, I am so excited. First of all, thank you for sharing that, Hugo. Thank you for the work, Damon. I am super excited for this partnership and the value that RLC Pro AI will be able to offer Azure users, making it easier, making it faster, driving adoption. Part of that kind of supporting this and other partnerships is going to be delivering containers for Pro AI, standard OCI containers, packaging all of the user space goodness in to compress that setup time. And in fact, when we come back, I think we'll see improved setup time for Damon's demos with some of the containers we'll bring forth. Next is going to be boot C. So we are able to capture sort of the speed and the tooling, which is predominant in AI, a benefit of sort of cloud native and Kubernetes native tooling, but with bare metal performance. And then the next step is to deliver those in workload with workload specific capabilities. So dynamic workload detection, coordination and concert between RLC Pro AI as a base OS and RLC Pro AI containers. And then the last thing I'm really excited, which actually someone is working on today that we hope to deliver this half, is actually going to be Pro AI containers that are compliant and security hardened when we talk sovereign AI. So really excited to bring those to market. Really excited to participate with Hugo and Microsoft on those.
Awesome. And Damon, last questions to you, my friend. If I'm a practitioner just getting started, what advice would you share?
I mean, read everything, break everything. The best advice I have, honestly, to anyone in any technology field, frankly, is don't be afraid to break things. Go hit your head against it. Go build something. Who cares if it works or if it doesn't work? You're going to learn something.
Maybe not in production, but overall, I agree with your sentiment.
Breaking production is the most fun way to do it.
I would go even a step further and go and show it. If you build this Q&A engine and you have sort of like uploaded some of your own docs and it can suddenly answer questions that it couldn't before, show it off. Make sure that you show it off to your friends, kids especially, and get them into doing this stuff as well.
Oh, thank you to our good friend Paul Brunk for posting the link on OpenEA. And you had the best question, Damon, by the way. I liked mine. It leads me to one that Hugo and I both had, is I say, just start. I run into a lot of people that say, what do I do? Like literally just think of anything you want to accomplish and start on the journey of trying to figure out how to accomplish it with and on top of AI.
Yeah, for sure. Yeah, don't get lost in all the different models and different layouts. Just try something. Just it's a running joke that by the end of the year I want to have a piece of hardware in my apartment that helps me co-DM Dungeons and Dragons, and that is still the goal. I'm still waiting on hardware, but just find a project, find a reason. When I started as a systems administrator and decided I wanted to get into home labbing, I wanted to be able to play Minecraft with some friends, and some of the public servers were just a dumpster fire. So self-host Minecraft. And then that led to Plex, that led to Nextcloud, and then that led to thousands of dollars of income spent, maybe not wasted, but spent on hardware and ridiculous hobbies. And yeah, it's a problem. But
trust me, then you get kids and you're starting to host Minecraft again. I've been there.
Yep, still have a Minecraft server, both traditional and Bedrock. So yes. Well, that brings us to time, and I really appreciate Hugo, Damon, and Brian. I really appreciate the three of you joining me today. The conversation's far more interesting when I have someone to talk to instead of just staring at the camera the whole time. But Hugo, especially, I know it's late where you are, and really appreciate you hanging out with CIQ and sharing your expertise. We might have to have you back to talk about the HPC space, because we have some tools in the HPC space, and I know we're working very hard with Microsoft on those platforms as well.
Look forward to it. Thank you so much. It was a blast.
Awesome. Yeah, thank you. So on behalf of my guests today and the entire CIQ team, thank you all for joining us. If you caught this live, thank you for jumping into chat. Always keeps things interesting. If you're catching this after the fact, make sure to check the show notes down below. We'll add some of those links to previous conversations that we've had, as well as some of the example instructions. So go out and try it, and then leave a comment. Please leave a comment. Let us know how your experiments are going. We'd love to hear from you. With that said, that kind of brings us to the end of our agenda today. I don't have a topic for our next webinar yet. We're shuffling some priorities around, but we try and do these about twice a month. So make sure that you follow CIQ and on social media. That way you can get notified anytime we release new content or new products. But until then, I've been Eric, the IT Guy Hendricks, and on behalf of CIQ and my guests today, thank you all for joining us, and we'll see you again real soon.